Thank you for joining the webinar today. My name is Emmett and I am joined by my colleague Andy Wedgwood. We will be discussing fall protection and working at height and what that actually means for you, whether you are a manager, operator or contractor. Working at height is a subject that can be unique to you and your site, and even specific tasks and applications, so we'll cover the basics, but if you do have any questions, please reach out at the end. Just a brief introduction on myself and Andy. I've been involved with the industry for over 8 years. During that time, I have worked on industry best practice guidance for Fatal 6 number 1, Latoto. Now working with MSA to help the industry on Fatal 6 number 3, working and falls from height. My colleague Andy has been involved in PPE and worked in fall protection for over 30 years. And together we have worked on various key projects with the industry today. So who are MSA? MSA are a global manufacturer of critical safety equipment which is used across many industries. Our headquarters is in Pennsylvania, USA. MSA was founded in 1914 by two mining engineers, John Ryan and George Dyke, and we've been leading the charge in safety for over 100 years. Our first major project innovation was the flameless electric cap lamp, which changed the way miners worked safely in hazardous areas. The innovation was adopted for decades, showing the true value of this innovation. And as MSA only manufactures safety products, it enables us to be more focused on our global mission. Our global mission is that men and women may work in safety and that they, their families and their communities may live in health throughout the world. MSA has 6 core product groups: fixed gas and flame detection, portable gas detection, including the industry-leading Altair range of monitors, industrial head protection, which includes the V-Guard brand, fall protection. Our global centre of excellence and manufacturing plant in Wiltshire is here in the UK, breathing apparatus for confined space working and emergency services applications, and finally fire and rescue safety helmets. We have over 15 manufacturing plants globally with over 40 locations, and we protect the lives of people in over 140 countries. So our aim for today, we will look at the theoretical and practical approach to keeping safe when working on exposed edges. We will look at increasing your knowledge in the selection process and safe use of PFPE by working through the hierarchy of control, the selection process, before identifying the most suitable piece of fall protection equipment and using it in the correct way. We will look into the regulations and standards which govern the way in which we approach working at height, and we'll engage with the Institute of Quarrying to learn and develop fall protection for the benefit of all. So we'll look at the responsibility, approach and common considerations. Firstly, we'll look at the legislation and specific industry standards that govern working at height. We'll go into detail on the hierarchy of control, the way we approach working at height, the collective control measures before individual. We'll also look at the technical aspects of personal fall protection equipment available in the selection process, and then we'll discuss the fall distances and ground clearance required, the pendulum effect and fall factors. The way we can categorise the severity of the fall will also be included. We'll also discuss the end users pre-inspection of harnesses and lanyards, the damage to look out for. And then finally, probably one of the most overlooked and crucial parts of working at height, the emergency considerations and the actions to take if you fall, and the potential development of suspension trauma. So now I'm just going to pass over to my colleague Andy, who will deliver the rest of the presentation. Thank you.
Thank you, Lee, and thank you everyone for joining us. Obviously we haven't got all day to go through the fine detail of EU and UK law, so I've put some bullet points here that are relevant to working at height in general, but also specifically for the aggregate industry, where particularly things like weather conditions can play a major part, not only in doing working at height, but in any rescue plan that you may have in place. So these will give you some ideas on how to identify the risk, put a plan together, make sure you've got a competent and safe workforce before you start to do the work. This is 2020, so most people have got this covered. Maybe not every fast food restaurant in North Derbyshire, where this is the preferred method of adding their latest promotion using swivel stools. Or these guys here working in the hot sun, far too hot to wear a helmet, a harness, or indeed even a shirt. Two real examples that I took myself. If you are working at height, please try to follow best practice, good practice, such as the hierarchy of control, So on the top of the pyramid there, if you can avoid working at height, please do so. There is equipment now available that certainly helps with that. Drones are becoming ever more popular for survey, inspection and security work in particular. If that's not possible and you still need to get to a height, then try to use some mechanical equipment that's going to help you with that. So this guy's turned up with the correct mechanical equipment. He's got his MUPE, and you can take that mobile elevated work platform up to the correct height while staying safe within the cage. Another example would be, this is a temporary barrier system that we manufacture called VersaRail. Now the beauty of this is it's not just individual protection, this is a collective measure. So this can protect a group workforce from ever getting to a risk area. Temporary, so it's a weighted system that can be removed and moved on to another area of site. Another example would be scaffolding, but you may have to call scaffolders in, contractors in to do that work for you. If you can't avoid working at height and you need to wear some form of personal fall protective equipment, then here's an example of somebody on a quarry in the UK who's wearing the correct PPE, the correct harness. He's working on a vertical ladder or gaining access through a vertical ladder. He's got a trans-fastener or travelling device moving up and down on a fixed vertical cable man-safe system, and therefore if they were to fall at any point, their fall would be arrested very, very quickly. If you don't want a fully engineered system, here's another example that you can use. This is an SRL, a self-retracting lanyard. So we manufacture these from 6 meters up to soon to be 30 meters. And if you connect that at the bottom of the ladder as you climb, should you get into difficulties, that's going to arrest your fall pretty quickly. We usually work between 300 to 500 mil as a typical example. The rescue plan for this very often is a simple self-rescue, reaching out, feet and hands back on the rungs of the ladder and away to do the work. So typical hazards, we've already dealt with the vertical ladders there. That's a typical image from a site in the UK. This one too. Okay, it's a dry day, the sun's out, everyone's stood on terra firma. This potentially isn't a working at height scenario, but if the weather changes or it's been torrential rain for the past 3 days, or there's snow and ice and strong winds, potentially this could be a working at height hazard, and you need to consider that. Another example here is this working at height. Well, we've got a permanent barrier system and a permanent walkway system, so potentially it's not working at height. But we were called into this project in the East Midlands to look at maintenance work on the conveyor belt in front and the conveyor belt to the right that were mobile conveyors, and clearly that meant getting across the barrier and a working at height scenario. Usually once or twice a year I get into a heated discussion about whether confined space is working at height. It clearly is, that's what the legislation tells us. If the manhole cover was in place, then that's perfectly safe, you're on a flat working surface. But as soon as you open that up to do some work, you can either fall down the hole if you're an observer, or you can get into difficulties as you climb down. And here's part of the definition of working at height. When you add the risk or the potential personal injury to that, you can see how it is definitely working at height. Under protection, unfortunately, is all too obvious. These are the official figures, the latest figures from 2018-2019. where 40 workers who never made it home, unfortunately. Working at height related deaths is still the largest single cause in the UK and Europe. Overprotection is becoming more in people's minds. The image on the far right here, the guy is far too confident in the protection that his PPE is giving him. If you can't fully support your own body, then really you need a secondary device there to keep you safe, so maybe some form of work positioning belt. Added equipment, we can put extra padding and extra tool belts and extra work positioning belts and such like onto a harness, but we're also aware that that's increasing the weight of the harness and therefore potentially the heat stress or other stresses on the body through the working day. So that maybe needs to be given some consideration, as does over complexity. We have a legal and moral obligation and duty of care to make our products as simple to use as possible, and we take that very seriously. If not, they're not going to get used properly, or potentially they're going to get left behind and not used at all. Training and understanding, which could be as simple as a free of charge toolbox talk on site, are available. If you need something more complex, basic working at height, competent person, or something more bespoke, then we can help you with that. Personal fall protective equipment is as simple as A, B, C. So probably just as important as the hierarchy of control, if you remember this principle, then you won't be going far wrong. So A, for the anchorage point, you must have a safe anchor. Body support, usually a harness, so that protects the body in a fall. And the connection device between the two, either to prevent you from having a fall or to protect you if you do. Examples of types of anchors there, various different categories that are available, some permanent, some temporary, typical movable tripod there in section B that can be moved around the site, or section C there where you've got a steel cable to go potentially around a girder or something like that. These are also available as textiles. Example E down at the bottom there, that's a section of heavy weights, so 25 kilos per weight, 4 weights per layer and 3 or 4 layers. Gives you a temporary but very strong anchor point should you be working at height. All correct equipment should be tested to EN 795. If you're incorporating non-EN 795 structural support, so maybe a steel girder as we talked about, then you've just got to make sure that that is sound and can take the impact during a fall, and then hopefully work with some EN 795 products around it. Connecting devices, remembering, going back to that hierarchy of control, if you must work at height, then please try to work in restraint when it comes to connecting devices. Typical example here, the guy's working 2.5 meters away from the edge. He's got a standard 2-meter restraint lanyard, so he can never get over that edge to get himself into a fall scenario. EN 358 work positioning, typical example on the pictogram on the left hand side there, guy working on a telegraph pole, attaches the belt before he goes up. He can rest halfway if he gets tired, or he can attach, or when at the top he's got both hands free to do the work. These should always be used in conjunction with a fall arrest system, as you can see the connection device at the back of the harness there on the pictogram. Fall arrest lanyards, either self-retracting lanyards EN 360 or standard lanyards EN 355. So this is what most people recognise as typical fall protective equipment. So the reason we know this isn't a restraint lanyard is it's got a shock pack or a extension device built into it at the small carabiner there, or you can use the smaller SRLs. We call them personal fall limiters, PFLs, which work in exactly the same way. As a manufacturer, we've got to ensure that your body is never subjected to more than 6 kilonewtons of force, and both of these pieces of equipment will do that. But why pick one over the other? Well, let's start considering how far you could fall, any swing or pendulum effect that you might have, and potentially the environment that you work in. Are you going to be falling over a sharp edge, something that we would term as leading edge? So the PFL on the right might be slightly more expensive, but it will arrest that fall a lot quicker than the lanyard that is built to go to its full length of 2 meters before the shock pack actually does apply. Ground clearance, this is part of that equation. So the length of the lanyard, 2 meters, or potentially shorter using a smaller SRL device, a PFL. The maximum energy absorber, so the shock pack, which could extend a further 1.75 meters. The height of the person wearing the harness, that's also part of the equation, and a safe distance which the HSE apply just as a safety factor of 1 meter. So a total of 6.75 meters, perhaps longer than you originally thought. Fall factors is a method that we use to grade how severe a fall has been. And we use a numerical figure between 0 and 2. This guy clearly hasn't worked it out correctly. He's fallen maybe 1.5 meters with a 2 meter lanyard, and he's got an injury as a cause of that. Simple equation, distance fallen divided by the length of the lanyard gives us the fall factor. Here's an example of fall factor 0, which we would always advise you try to work towards. So this is a connection point above the head, hopefully directly above the head, that's the ideal. Not always suitable for doing the work, but that's the safest option. So the rescue plan is very simple. You can see the guy's fallen off, but he hasn't fallen very far. And a rescue could even be as simple as stepping back onto the platform. 0 meter fall, 2 meter lanyard, fall factor 0. Fall factor 1, the next best option. So you're connecting roughly at the height of your chest or your dorsal connection on your harness. Rescue plan could be simple, could be a little bit more complex, somewhere in between. So you need to give extra thought to that. a 2 metre fall with a 2 metre lanyard, fall factor 1. Fall factor 2, although still legal, is the worst of the three scenarios where you have no option but to connect at foot level or even below. So you're going to fall that little bit further, and the rescue is definitely going to be more complicated. It may not be possible to recover back to the original position platform, so you may need to consider lowering down to the ground level. A 4 metre fall divided by the 2 metre lanyard gives us fall factor 2. Here's an example of a graph showing the kilonewton strain on the body if you'd picked the wrong lanyard. So you've picked a restraint lanyard by mistake and you've fallen off the edge. That's up to 20 kilonewtons, 20 G worth of stress on your body, way above the legal limit that we work towards. If you pick the right lanyard, either a mini PFL or the fall arrest lanyard, then you're down to the typically 3.5, 4 kilonewtons strain on the body. Pendulum effect we touched on, so if you can connect directly above your head, that would be brilliant. You're not going to swing too far. If you have to go further away from the body to the safest connection point, and if you're also working at a lower connection point, you're going to get more of a pendulum motion, and you could then make contact with other parts of the structure. Typical body support or body harnesses. So we've got a good range and selection here. So this one as a single point would be a single D-ring at the rear, perfectly suited, say, to the guy working in the MUP. The connection point is away from the front of the body, so he's free to do his work, but doesn't give you much chance to use that harness elsewhere on site, perhaps. So the 2-point typical UK specification here, front D-ring and rear D-ring. This is an inset picture here showing the rear D-ring in a relaxed position. You've also, with our harnesses or certain harnesses, you've got an extra connection channel there for some of the other fall arrest devices. So 2-point, very useful. Front D-ring for the scenario where the guy is climbing up the vertical ladder, and rear D-ring for other work. 4-point, so now we're incorporating the 2 side lugs here. So these are for work positioning, the guy who was climbing up that telegraph pole or something similar to that. You would never connect a fall arrest device to this because you would fall horizontally and the body would potentially snap. So you've got your front and your rear D-ring for fall arrest, and you've got work positioning devices here in the middle. The 5-point harness adds an extra ventral D-ring around the stomach area there. So you've got front and back for fall arrest, you've got side for work positioning, and you've got a ventral D-ring there, usually incorporated into a rope access application where you're suspending yourself with ropes, but you've also got the D-rings up the top here to accept the fall arrest device as well as a secondary safety device. We as a manufacturer are more than aware that everyone is an individual and everyone is a different shape and size. That policy has gone into a lot of the design of the new Race Flex design that we have here with these harnesses. Big spatial area out in the front here because of the X design of the harness. Big gaps here at either side as well to give free movement. And also that X design there is very comfortable for both genders. We build a range around 1.5 meters or 5 feet up to 2 meters, 6 feet high, and then 6'6", 2 meters, and 50 kilos, which is about 8 stone, all the way up to 22.5 stone or 140 kilos. I get asked quite a lot, do we attach to the front or the back? Depends on the scenario. If you're climbing a ladder, clearly the front is the way to go. If you're working in a MUP, the best one is at the back usually. But from a fall scenario, they both pass the EN361 test. If you connect to the back, there's a slightly reduced risk of a whiplash type injury, but the actual resting position once the fall has taken place is a lot less comfortable. And the opposite is true. If you connect to the front, once the fall has taken place, you're in a reasonably comfortable position while you await rescue. It's also easier if you have a self-rescue device, it's easier to apply from this position. Pre-use inspection on any harnesses or lanyards, you're looking for things like cuts, fairly obvious in 2 examples there on that image. You're looking for abrasion. This one looks like it's been around some rotating, moving device there. UV, so the sunlight, especially working in your environment, the sunlight can have an effect over a period of time. Contamination, this one looks like it's been exposed to some form of chemical or solvent, but things like oil or paint, they can also be a problem. The paint can discolour the harness, so you can't do a proper inspection. Burns, although we do specialist harnesses for high temperature applications such as welding, they will never fully protect against this kind of spotting. They will prevent from the harness bursting into flames or burning through. They won't sustain a fire, but you still need to do an inspection for any burn damage. Broken stitching, one of the hardest things to pick up on a visual inspection, and we'll deal with that in the next slide. Make sure the label's in date, make sure it's got a label to start with and it's to the correct standard, but has that been also annually inspected? Fall indicators aren't part of the EN361 standard. We believe that they should be. We put 2 fall indicators on all our harnesses. If the fall creates a force greater than 2 kilonewtons, they will deploy, and it's a clear indicator to the next user of the harness that that has been involved in a fall, and it's very similar to a seatbelt in a car. When it's been in a crash, you have to replace them. Hardware. So here's some deformity in the steel D-rings there. Here's a degradation of some form of coupling, so that could be potentially steel against aluminium degradation. And this hook, really, you probably won't be able to open it to use it anyway, but it's clearly past its sell-by date. If not the hook, then certainly the rope as well. So we talked about the stitching. MSA have adopted, after doing quite a lot of trials with the Massachusetts Institute of Technology, the MIT over in the USA, and we did a lot of work on how the eye picks up on deformity of shapes. So we went for this tessellating hexagonal design rather than the mismatch of mixed stitching over on the right. So when you do have a missing piece of stitching, the eye is focused on that point a lot quicker because it's looking for a natural shape, as opposed to something like this where there is also a missing stitch, but it's a little bit harder to pick up on. So just to prove there are missing stitches, these are the 2 examples that I chose. You should never work at height without having a rescue plan in place. That's the simple rule. You can no longer rely on the emergency services to come to your rescue. They do not prioritise working at height rescue if they get called to another incident, and they expect you to have your rescue plan already in place. So not only a legal requirement, I think we'd all agree, and moral grounds as well. If a colleague's in trouble, you want to rescue them as soon as possible. So you'd look to normally rescue within a 10-minute window or 10 to 15 minutes. People talk about suspension trauma, where the blood in the legs pools because of the tension around the groin area from the harness. There are some equipment, some movements that you can use to alleviate that. Typically a stirrup that sits in a pouch in normal day use, but can be deployed if you are involved in a fall, and you can put your feet into the stirrups and self-support while you wait to be rescued. The ideal, of course, is rescue as soon as possible. So here we've got this guy here in this fall situation on the right, where fortunately he's wearing the MSA personal rescue device, the PRD harness. So this has a little backpack on the back with 20 meters of reinforced Kevlar rope, and a similar action to a parachute. So you pull out the red cord, you pull that, and that deploys the rope, and you eased down to the ground at 1 meter per second up to 20 meters. Again, going back to the hazards, particularly in your environment, in your working environment, the weather can change. That might affect the actual working at height, but it also might affect the rescue plan that you've put in place. So hopefully we're feeling a little bit more secure from the starting position. We have a better understanding, if not of the law, but certainly where to find the law and where to investigate what we need to do. You're better equipped to identify the hazards and particular hazards to your workforce, workplace. You can build a plan based around that and follow the best practice that we've discussed. Pick the right equipment for your application, that right blend of comfort and application. Get your staff trained to the right level so you've got competent people on site doing the job, and then, as you would with any safety policy, you go back and review what you've agreed. I'm going to hand you back now to my colleague Lee. Thanks for your time.
Thank you, Andy. As we're nearing the end of the presentation, I just wanted to point you towards a few resources and tools that MSA can offer to help you promote good practice when it comes to working at height. We have our industrial demonstration truck, which is available. It can come to your workplace. As you can see in the pictures, it gives you the ability to get hands-on with the products, ask specific questions, and it just raises awareness and promotes good practice. We also have our virtual reality simulator. This technology gives you the opportunity for from the comfort of the ground to perform a task working at height, which gives you the real feel for what is needed or what it feels like to be working at height. Lastly, we have MSAU, which is our online e-learning platform. We can give you access to the portal, which gives you the ability to look at specific products and applications to further your knowledge. Okay, as we're at the end of the webinar now, I'd like to take this opportunity to thank you all for attending and taking the time out today. I hope you found the content interesting and provided much food for thought. Working at height is such a broad subject. We've covered the basics today. But if you have any specific questions or applications you want to ask us or us to have a look at, please feel free to reach out. Lastly, please remain safe and take care. Thank you.